Hello again. So, what we just did is we used the philosophy of SOHCAHTOA, the fact that trig functions give you information about right triangles conversely, in order to do some applications. Today I want to do another type of application. I want to use this philosophy to evaluate trig functions at some carefully chosen values. So we've done some already. For instance, I know what the cosine of 0 is. The cosine of 0 is 1. The sine of 0 is 0. The tangent of 0 is 0. I know what the cosine of pi over 2 is, right? That's a right angle. Cosine of pi over 2 is 0. Sine of pi over 2 is 1. Tangent of pi over 2 is undefined. I want to fill in the same information, but for three other angles. Pi over 6, pi over 4, and pi over 3. And in fact, what I'll do is I'll record that information in a unit circle, which I'll have off to the right. Give me a second and I'll pull that up. Alright, so 6 pi over 6 minus pi over 6 is 5 pi over 6 minus 3 pi over 6 leaves me with 2 pi over 6, which is equal to pi over 3. So that means this angle alpha is pi over 3. Now the red triangle is built by reflecting the tan triangle, so this angle is the same as this angle must be the same size as that angle. So that bottom angle is also pi over 3. But check this out. This blue angle is built out of an angle of pi over 6 and another angle of pi over 6. So that angle must also be pi over 3. So if you look at the big triangle, that is the triangle ABD. Look at those angles. They're all pi over 3. In particular, they're all the same. So this is a triangle where all of the angles are equal. That must mean all of the sides are equal. That is, this triangle ABD is an equilateral. What does that mean? That means all of the side lengths are the same. Let's write down all the side lengths. So that means that this side length A, must be equal to this side length. 2C must be equal to this side length A. So that means, well, maybe I'll write it as a sentence first. The line segment from A to B, the line segment from B to D, and the line segment from D to A are all the same length, which means that A is equal to 2C is equal to A. Okay, so the first and last A, one of the two is redundant. You already know that A is equal to A. What's important is A is equal to 2C. That tells me what C is. C is equal to A over 2. That's handy. So I'm going to redraw that northern triangle again. So that top triangle has an angle right here of pi over 6. It has a hypotenuse of length A. It has a base of length B. It has a height of C equal to A over 2. But this is also a right triangle, so there's a relationship between the three sides, namely the Pythagorean formula, which says that A squared is equal to B squared plus C squared. So that means that A squared is equal to B squared plus A over 2 squared. I need to solve this for B, I guess? That would be handy anyway. So let's see, I'll rewrite that a little bit. That's A squared equals b squared plus a squared over 4. So let's see, I'll subtract a squared over 4 to the other side. That will leave me with 3a squared over 4 is equal to b squared. Now I can solve for b by just square rooting. B is equal to a square root of 3 over 2. So put that right here. B is equal to a times the square root of 3 over 2. Now I can use SOHCAHTOA. So SOHCAHTOA, sine of pi over 6 is opposite over hypotenuse. So that means that sine of pi over 6 is c over a is equal to a over 2 divided by a. Hey, that's just a half. Cosine of pi over 6 is b over a. Cosine of pi over 6 is b over a. I know what b is. B is a times the square root of 3 over 2 divided by a. Oh, so the a's will cancel and you'll just be left with root 3 over 2. Tangent of pi over 6. So TOA, SOHCAHTOA. That means that the tangent of pi over 6 will be opposite, so c, excuse the typo, divided by adjacent, b. And now we'll just write that in. Tangent of pi over 6 is c over b. That's a over 2 divided by b is a times the square root of 3 divided by 2. And lots of stuff cancels. You see both the numerator and denominator are multiplied by a. So those a's will cancel. Both the numerator and denominator are divided rather by 2. So those will cancel. That leaves us with just 1 over root 3. I see a square root in the denominator. I should rationalize by multiplying, dividing by square root of 3. That'll leave me with root 3 over 3. Very nice. So let's go ahead and take that information and write it in the unit circle up at the top of this packet. So here we are at the top of the page. The cosine of pi over 6 is root 3 over 2. Sine of pi over 6 is 1 over 2. Tangent of pi over 6 is root 3 over 3. That puts us over here. Root 3 over 3, comma, 1 over 2. Very nice. So let's go back to the bottom of the page. There's one more observation to make. Sorry, bottom of the page there meant the end of this packet. We can also figure out the same thing for pi over 3, because this angle right here is pi over 3. So we can play the same game, SOHCAHTOA. So the sine of pi over 3 should be, so sine is opposite over hypotenuse. So sine of pi over 3 will be opposite over hypotenuse. That's b over hypotenuse is a. So the sine of pi over 3 is b over a. B is equal to a root 3 over 2. Divided by a leaves us with just root 3 over 2. Similarly, we can compute the cosine of pi over 3 by looking at this picture. So cosine, ka. Cosine is adjacent. There's pi over 3. The side adjacent to pi over 3 is c. Hypotenuse is a. So cosine of pi over 3 is c over a, which we know what c is. C is a over 2. So this will be a over 2 over a. That's just a half. Finally, tangent. Tangent, toa. Tangent of pi over 3. Tangent is opposite over adjacent. So that's b over c. Will be b over c, which is equal to b is a root 3 over 2, c is a over 2. And you see that simplifies to just root 3. The a's cancel and the divide by 2's cancel. So let's go ahead and put that also at the top of the previous page. There we are. I've just filled in cosine of pi over 3 is 1/2. Sine of pi over 3 is root 3 over 2. Tangent of pi over 3 is root 3. Migrating over here means this is 1/2. This is root 3 over 2. Nice. So here are the important takeaways from this particular video. So I've just explained how to figure out what those values should be in the unit circle, but it's more important to know what those values are, and to also remember this philosophy that if you have a right triangle, you can use that right triangle to tell you things about the angles you see in the triangle. You can use it to write down what the trig functions evaluated at those angles are. Excellent. So that completes this lecture. I hope that you enjoyed it. I'll talk to you later. Maybe one more thing. So you'll notice that there are like 3 quadrants that we haven't touched in this unit circle. We'll come back to that in the next lecture. Great. Now I'll stop.